Hello and welcome back. This will be the first video on Chapter 1. So Section 1 is on the Cartesian coordinate system. So we'll be looking at graphing equations and interpreting graphs. So the first thing that we should do is establish some vocabulary. So the Cartesian coordinate system is also called a rectangular coordinate system because it's fairly rectangular. And when we look at a graph like this, we're going to have the two main lines, the horizontal line and the vertical line. The horizontal line is called the x-axis, and the vertical line is called the y-axis. And when we want to talk about places inside of our coordinate system, we'll give them a name where we list the x first and then the y. So let's plot a few of these. So each of these dashed lines along here will correspond to a number. So we've got 1, 2, 3, 4, -1, -2, -3, -4 going to the left. Going up along the y-axis, again we have 1, 2, 3, 4, and going down -1, -2, -3, -4, and these extend forever in every direction. So we could look at more of this, but it would get a little bit hard to draw if we kept going. So for instance, the point 2, -3, remember the first coordinate is always the x coordinate, and the second coordinate is always the y coordinate. So first we go to x is 2, so we're going to go 2 to the right, and then y is -3, which means going down 3. So this point here is going to be 2, -3. So this is a fairly simple formula to follow. So 4, 4 means that we're at 4 along the x-axis, so 4 to the right, and 4 up, 4 along the y-axis. So this is 4, 4. 0, 0 is the point right here in the middle, and 0, 0 is also called the origin. And the origin is essentially the sort of a base point for the plane. It's something that we know will always exist essentially, and we know where to find it. It's sort of the easiest places where the x-axis and the y-axis intersect. We can also look at half coordinates, and this is maybe a little bit harder to see. So for instance, at -3, 1/2. So again, the first coordinate is always the x-axis, the x coordinate. So the x coordinate here is -3, so we go 3 to the left, and we go up 1/2. So we're up just a little bit. So this is -3, 1/2. So we can plot points for days, but something maybe a little bit more interesting will be graphing equations. And the way this works is we'll have an equation that will relate two variables. In this case, we are relating x and we are relating y. And when we're graphing an equation like this, one of the simplest ways to go about this is to plug some things in for x and see what y is equal to, so we can establish the coordinates. So for instance, if we plug 0 in for x, what we will have will be y is going to be 0 squared minus 4. 0 squared is 0, 0 minus 4 is going to be -4. So the coordinate is going to be 0, -4. So when x is 0, we are right. We aren't any to the left or to the right. We're right in the middle. And at -4, we're going to be down here. So this point, maybe I can make this a different color, will be one point that lies along our line. And then we can start plugging in more values for x. Plug in a 1, y, which is going to be x squared, so 1 squared minus 4. 1 squared is 1. 1 minus 4 is -3. So when x is 1, y will be -3. So we can plot again. When x is 1, we'll come 1 over to the right, and -3 will be down 3. And we can continue doing this. So with x is 2, or x is 3, so 2 squared minus 4. 2 squared is 4, so 4 minus 4 is 0. And 3 squared will be be 9. Minus 4 will be 5. So these points would be 2, 0, and 3, 5. So these next couple points, 2, so the point 2, 0, we come over on the x-axis 2 points, and but we go 0 up and down. And then 3, 5, we go 3 over and 5 up, so this will be just off the chart a little bit, but up there. So we know what happens to the right on this axis, but what happens over here to the left? Well, those will be when x is negative. So we can plug in a -1. I should show the equation again. So when x is -1, we'll take -1 and square it and subtract 4. -1 squared, -1 times -1 is 1, minus 4 is 3. -2, -2 squared is 4, minus 4 is 0. And -3, -3 squared, -3 times -3 is 9, minus 4 is 5. So we have some other points to plot on the other side of the y-axis. And as we plot these, so -1, -3, -2, 0, and then -3, 5, so it'll be way up here. And then, technically speaking, I don't have to just put integers in here. I could put things in between, so say 1/2 or 3 3/4, and continue to fill out this line with lots and lots of dots. But when we see something like this, we can try to begin to imagine that there will be some pattern here, and if I could draw straight lines very well, we might see something that looks like this U-shaped. We will see more of what sorts of shapes these equations can be later on, but for this chapter we just want to plot some points and sort of connect them using a little bit of intuition. So these lines would technically extend forever, sort of going up and up and up, but within this range, this is what the function will look like. Let's do this for one more example. Here we'll have y is equal to the absolute value of x. So I know that I want to plot the points from, say, -3 to 3. So I'll just list all these integer values, and all we're going to do is we're going to take the absolute value of these guys. So the absolute value of -3 is just 3. The absolute value of -2 is 2. Of -1 is just 1. The absolute value of 0, is not 1. It is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. And the absolute value of 3 is 3. So it's fairly straightforward. So the coordinates here are going to be -3, 3, -2, 2, -1, 1, 0, 0, which is the origin, 1, 1, 2, 2, and 3, 3. So as we plot these, we'll have -3, 3, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2, and 3, 3. And this looks much more like a sharp corner, and in fact it will be. So an absolute value will come down and it will make a V shape. In the homework, they'll give you some functions that you'll plot in the same way. They'll ask you to list some of the values, plot those points, and connect them with some lines. And when we are drawing lines, one important feature of a line is going to be its intercepts. And this is where a line is going to meet an axis. So an x-intercept is where it meets the x-axis, and a y-intercept is where a line will meet the y-axis. So here's a fairly simple line, and if we're going to look for the x-intercept, we have to remember that this axis, the horizontal axis, is the x-axis. So the x-intercept is going to be where our line hits the x-axis. So this is going to be the x-intercept. And that point there, we can count backwards. So this will be 2 backwards. So this is going to be at -2, and we're not up and down at all. So -2, 0. And quite often, when people will ask you what is the x-intercept, we know that the x-intercept has to be when the line hits the x-axis. So it can't be up or down at all. So we know that the second coordinate has to be 0. So by saying that the y-coordinate is 0, that's not really giving us any information here. What's more informative is to say where along the x-axis did the line hit. So the x-intercept here is just going to be -2. And we know that when we say -2, what we mean is the line will hit the x-axis at -2, 0. Furthermore, we can do the same thing for the y-intercept. Again, the y-axis is the vertical axis, so the y-intercept will be going, is when the line hits this y-axis, and this will be at 0, 1. Let me write that 0 a little bit better. We know that the first coordinate here has to be 0 because we can't be any to the left or to the right. We have to be exactly on top of the y-axis. The question then becomes, where at along the y-axis did we hit? Well, at 1 up. So here, the y-intercept is going to be 1. So if you're asked what is the y-intercept or what is the x-intercept, they're looking for a single number, knowing that it's actually a pair of numbers, but we're only interested in the one that's not 0. There are a few other situations that could happen. So for instance, I could have a line that does something like this. What you'll see is that we do have a y-intercept, but there is no x-intercept. So there is one y-intercept, and there are no x-intercepts in this graph. I could do the same thing doing something like this. Here we have one x-intercept, but we have no y-intercepts. This line here does not cross the y-axis at all. More situations that could happen, you could have more than one intercept as well. So for instance, if I had something like this. When we look at this, again, we only cross the y-intercept once, so there's only one y-intercept. But when we look at the x-intercept, remembering the x-axis is the horizontal line, there's 1, 2, 3 x-intercepts. So when they ask for an x-intercept, you need to know how many are there. Are there no x-intercepts? Is there more than one? And how many? This same line I could draw sideways, and we can see that here, again, I'll only have one x-intercept. There's only one place where our line meets the x-axis, so there's only one x-intercept. But there are, in fact, 3 y-intercepts. And ultimately, we might not have any intercepts. So for instance, if I drew a circle up here, the circle doesn't intersect the y-axis or the x-axis, so there are no intercepts at all. But depending on where the circle is, I could have some. So for instance, if the circle was around the origin, then I have 2 y-intercepts and 2 x-intercepts. And I'll do more in the next video.